Ooh, oh boy, are we getting in the thick of it or what? Oh my goodness. Welcome back. We're on episode 4 of making this RPG, and things are about to get really interesting. Okay. Little forewarning, foretalk, foreplay, whatever you want to call it. Uh, all right, so episode 2's people left some comments, and I said I would address them in episode 4, and I am doing that. And this has taken me 2 shots. I did a full recording of this once and scrapped it. So yeah, I just wasn't happy with it. I thought it'd be more confusing because it's a long story. But I am going to put that outtake episode up on Patreon and on the YouTube members. So you can see it if you want, if you're a supporter of the channel and you want to see some outtakes and some blunders or whatever. It's actually got some decent lessons in there, C++ wise, if you ask me. But overall, we're scrapping what I did there. So this is the real episode 4 now. I took some time, quite a bit of time, and researched and redid and reworked and came up with the best solution I could for our case. And I also learned quite a few things along the way. So I just really want to thank you guys for leaving comments and even leaving criticism. I really appreciate you. I think at some point here near the end of this series or after we've been going for a while, I'm going to do a super big giveaway, and I'm going to enter in everyone that's left a helpful comment. As far as that, I don't want to make that too uh, formally set in stone, but I want to do something to give back to the people that are working to make sure that this is a proper lesson and not letting me just go off into the void with my craziness or whatever. All right, so with that out of the way, we are going to delegate these character classes away, because what we want to do, and I have here in the main, and I'll show you the code. We're going to walk through all the code. I'm going to walk through what you need to change and all that to get it to this state as well from where we last left off. So yeah, and by the time episode 2 released, episode 3 had already been recording. That's why I said I'd address everything in episode 4. And oh geez, I guess there's a few more things I want to say. So I think I'm going to space these episodes out a little bit. I was releasing them as quickly as I could. All right, very good. Just turn my phone off. It's that time of day when it's just going to start beeping every 2 seconds, because apparently this is the time to send emails. Where was I? Get sidetracked. All right, so yeah, we want to basically what we want to do is we want to be able to say, hey, let's make a player character, and we'll give it whatever type we want. Is it a rogue? Okay, it's a rogue. You hit play, it does all the rogue stuff. Is it a warrior? Cool. Then just instantiate it as a warrior, does all the warrior stuff. So we just want to delegate and forward everything properly. That way, this is easily extensible in the future. If we want to add a new class or later, like berserker, we'll be able to pop that in easily, as you'll see. But this makes it easy, I think, and this is a pretty good long-term method that's a little more boilerplate, as you'll see, but we're gonna walk through it all, and you're gonna learn some stuff about delegation, inheritance, composition over inheritance, or something to that effect, which we're gonna talk about as well. So there's gonna be a lot of that sort of talk, and some of it's my opinion, some of it's more set in stone, some of it's still up for discussion as we're going to review as well. So let's do a little reviewing of this whole composition over inheritance and OOP class design, and which class type is best, which way of doing things is best. Let's just talk about it a little bit, help you get an understanding. I'll leave links to all these articles down below. Okay, so the first thing I think is really worth looking at is the Wikipedia page on this. If you just type in composition over inheritance, one of the first links is this page here. And it's a good read. It's well worth reading, and it's got some important lessons in it. Now, this is kind of language agnostic, and different languages handle this in different ways. That being said, we are sticking to the C++ theory of it the best we can, but also we do just have to make some design decisions in our program, and there isn't necessarily a hard and fast rule that applies perfectly, and you'll find that happens a lot when you're programming. And another thing I want to say, I keep interjecting with things that I thought of randomly throughout the night and such. This is often the point where things get a little more complicated in your software or in your program, or and if it's a hobby program, This is where a lot of people stop. I'll even say up to 90%. Like 9 out of 10 people at this point in writing a piece of software will quit. And that's the important thing. Push through, don't be a quitter. If it's important to you, find a way to keep going. So that's what I want to say on that subject. I think that's an important lesson. You see a lot of people dive into something all gung ho, ready to go. They run into some trouble and they just quit and give up. And that might be understandable in some cases, but if it's important to you, find a way to keep going. Because I felt that. I felt the urge. It like came down over me and was like, hey, you're in over your head. This is getting really complicated. Maybe you should just call it quits. And that was just like an internal dialogue. And the real me was like, what, are you kidding? No, we're not quitting. This is an opportunity here. This is a moment that's going to be the most important of the series probably. So keep that in mind when you're running into trouble like that. It is often the most important defining moment of your piece of software, of whatever you're doing. So embrace the trouble and think on it. Take a day off if you need to. Take a walk, all that sort of stuff. It means a lot. And leave your inspirational quotes down below. All right, so what is composition over inheritance? Basically, there's a few rules here. And there's some, these are not hard and fast rules. These are kind of theoretical rules, if you will, and kind of guidance rules. There's a has a and an is a type thing. So if you're talking about some particular thing, like let's just go with their example here. They have a duck. A duck, what does a duck have? And what is a duck? And there's stuff like that. So for example, we have a mallard duck. A mallard duck, it is a duck. So it should inherit from duck because it is a duck. A duck is also an animal or a bird, so it should inherit from bird if they have that. But what does it have? It has wings and can fly. So since it has that, but you can't say it is a fly. That doesn't really make sense. It has the composition of some fly behavior inside of it rather than inheriting. So if it is a something, you usually want to inherit. If it has a something, you usually want to compose that within it. So you could design like this fly behavior as a struct or something and just use it as necessary within maybe many different classes or wherever needed, because a lot of different things can fly that aren't necessarily ducks. So I hope that makes sense. We'll get into it a little more. We'll talk about this a little more. But let's go down here a little bit and just talk about this a little bit so we can kind of get a base understanding of where we're going with this. All right, I like this example here. So we have this pure virtual function of a collision delegate. Hope I'm saying that right. And it just takes some objects. You don't really need to worry about exactly what it does, but it just has a pure virtual thing. It's called a delegate. So this is the one we want to work off of. So in their case here, they have a solid and not solid object. Of course, the not solid one, they're going to override this collide and have it probably do nothing because it'll just, everything will go through it. It's not solid. And they also have a solid version where it's actually going to check for colliders and do stuff. So what you'll see here is, so what do you do with this? Not solid and solid. What you do is you make yet another class that has a pointer to a collision delegate, and you can instantiate it using some polymorphism power as not solid or solid, as we'll see down below here. So we have this object, and privately it has a collision delegate. It's just a pointer, so it's going to start out as null, pointing to nothing. But when you construct this object, you got to pass it whatever you're turning it into. So here on this constructor here, they could pass a new not solid or a new solid, and it'll turn that into what it is. And then here, when they go to collide, it'll call the proper collider. It'll either be calling the collider for solid or not solid, and work properly from there. So that's basically what we're talking about when we mean these delegates. So then going forward into the actual code where they would write this, they have say a player who is an object, and they're going to instantiate it with some features. We're looking at this solid one. They're putting in a new solid. So the player is going to collide. And here we have a smoke one that they're making an example of, and it is not solid, so it is not going to collide. And they did essentially the same thing for visible and movable. They had like a not visible, visible, but essentially the same case, just another example. So that's kind of the big thing. And yeah, this is somewhat language agnostic. Most languages have some way of doing this, so you might have to look it up for your language if you're following along in a different one. But I'm going to leave it at that. I'm going to leave a link down in this article. Highly worth studying if you don't understand this fully. And I would almost even say at this point, don't worry too much about understanding it fully. Just get the gist of it here and get some practice with it, and it'll click more and more the more you use it. Okay, and I actually found some good discussion on the subject over on Stack Overflow. This one I thought was pretty good. So let's have a gander at what they were talking about here. Super old, asked 13 years ago. Yes, Stack Overflow used to be pretty good. People used to have pretty good discussions on here. It's pretty rare to find these days, but I felt like this was pretty relevant to what we were doing. Someone basically just asked, which design is better? All right, they have a user, an employee inherits from user. And yeah, just basically something like that. They were just trying to figure out basically the same thing we're trying to figure out here. And then they have another version here where they have an employee that has a user as a field here rather than inheriting from it. And a member that also does too. So just kind of the same thing we're running into. And some people had some good answers here. And of course, we talked about the is a and a has a relationship, which we already kind of talked about. And this is a good general rule. But something really important is said here that I think gets overlooked. Human languages are vague and imprecise. Programming languages can't afford to be. So while you can kind of use this as a you can say it in English and get an understanding of maybe how you should structure it. Just because it makes sense in English doesn't necessarily mean that's how you should be doing it. So there's some other things we need to think about. The is a and has a is a good general rule to follow, and probably 99% of the time, or 95 or something, but most of the time it will work for making sense. But sometimes it won't. So the stuff we were doing in episode 2 was somewhat technically correct, like it would work, but it depends how we're going to reason about these variables and classes in the long run also, which we will get into in a little bit. Okay, someone says I don't like either one. What happens when someone is both a member and an employee, right? Yep, so we're running into some trouble. And here's another comment that I thought was really good. Okay, so we have the is a and has a question. Good. If it is a user, use inheritance. If it has user information, use composition. Okay, there's that. But also a couple other just really important questions. If there's virtual functions involved, use inheritance. All right, so this is another thing to think about. If there's virtual functions involved, use inheritance, which we do see some in ours. So, but we'll get to that. And can it have multiple instances of the thing? If so, use composition. So if it can have multiple instances of something, don't use inheritance, because what if it needs to have multiple? And we could see that. We can see that some. We'll get into that too, because we are going to talk about that. And does it make sense to employ or to assign an employee object to a user object? So use inheritance. So we'll talk about that a little bit too. All right. And yeah, one of them allows polymorphic behavior. So where we want to use that polymorphic behavior, we want to be sure to be using inheritance. If we don't need the polymorphic behavior and we might want multiple and it's more of a has a, then we're going to use composition. Otherwise, inheritance. So cool stuff. All right, so let's dig into the code and let's write it. Now, I really hope you'll leave a like and help support this particular series, and especially this episode, because this, like I said, is probably going to be one of the more important episodes as far as learning some of this stuff, and it's by far taken me the longest compared to any of the others so far. So yeah, with that, let me get some stuff prepared, and we're gonna start coding. So get your code fingers ready. Okay, so as you can see here, I made another branch called class delegation. I did not push this branch because this is basically one where I was just testing a bunch of things and trying to come up with the method that I thought worked for our best for our case. So that's one of the things when you're writing your own software, working on something, you just got to come up with the best case for what you're doing. You're very, very rarely going to find the perfect answer for almost anything you're doing creatively. And I think I came up with the best one that seems to work pretty good. So what I'm going to do is just go back to our main branch and kick out all these changes. And we're going to just make these changes throughout this episode. Let me just do that real quick. So changes. We're just going to stash all, I suppose. Stash all, sure. And there we go. We're back to our old original version. That is exactly where we left off on episode 3. All right. So in our main here, first of all, let's go ahead and just get rid of one of these. We're only going to need one of these really to test. And we're no longer going to be instantiating each class individually. We're instead going to be pulling something like player character and give it whatever name you want and instantiate it as a new and then whatever class you want. And it should handle it from there. And we no longer want to say cleric here. This is just sort of some front end so we can run the test when it works properly, but sometimes you would do this part last. Complete P1, we're going to have a get class name. That way, whatever class it is will just automatically populate the name correctly. And then we can get rid of cleric there. Still want a space, then level, and then these are all going to be the player P1 or whatever you named your variable. And we'll clean this up a little more than just that. But essentially, we want to do kind of the same thing. We just want to get a little stat sheet, give it a level, see, make sure it's leveling up correctly, and check those base cases there. And as you can see, it's not happy right now. We're going to have player character instead. This is just, yeah, you don't necessarily have to do this first. You can do this last if you want. But this is what we're aiming for. We want this to work correctly. All right, so we have all these things. We're going to condense this down and simplify it a lot, and it's going to be a lot better. All right, so first of all, where do we start? All classes here. We're not going to use this anymore, so we can delete this all classes file. And we're just going to kind of go through and clean up as we go. Cleric, yeah, we're going to merge the cleric, rogue, wizard, warrior. We're going to merge all of this into one file. Right now we have a level system. In this level system, we're just going to change this. This level system we're going to turn into player character. This is going to be our big player character file that does and handles everything. It has all the boilerplate to make some nice expanding later. So this level system is no longer going to be just level system. It's going to be player character delegate. So this is going to be our pure virtual, basically base class for our players. And we're going to keep a lot of this stuff. We're going to, of course, rename the constructor and anything else we might need to rename. But for the most part, it's actually going to stay about the same here. So every character is going to have the ability to level up, but you can see level up is going to be pure virtual. So we cannot instantiate this player character delegate. We can only inherit from it. And that's going to be the big point here. So let's go ahead and bring in our classes one at a time. So let's take this cleric and we're just going to copy all this. Go down into here and paste it down below. And there's our cleric. We can now get rid of our cleric file and we'll fix this up. Let's go one at a time here. Let's see here. All right, so now we have cleric inheriting from stuff. Of course, we want level system, right? Or do we? That's kind of a question here. Yeah, of course we do. Player character delegate. Do we want stat block? We're going to do stat block and HP differently. So we're actually going to delete those. All we want to inherit from as a Character classes, player character delegate. Player character delegate should be able to handle as many things as possible. And now we need to make some design decisions. Is a player character a hit point? Or or that sort of thing. No, I wouldn't say so. So many different things could have a hit point. So we're going to rework the hit points and call it something different. We're no longer going to inherit. We're rather going to use composition there. Is a player character a stat block? I'm going to go with yes on this. Now, this is debatable, of course, but you hear this a lot. You hear this a lot in games. Have you ever heard that so-and-so character is just a stat stick because they've got huge stats? I think you can call characters stat sticks or stat blocks. So we are going to inherit from this. I think it makes sense in our case. And also, as we were talking about those rules we mentioned a little earlier, you never want more than one stat block. Only one stat block, and you always have a stat block. So in this case, I think it makes sense that we inherit stat block. And we're going to, of course, need to include stat block. And that's pretty good. And of course, later, when we make like monsters and NPCs and stuff, they're also going to use the stat block too. Because, yeah, they're going to be stat sticks too sometimes. So, yeah, this one I think it makes sense to inherit from just because you never have more than one. There might be some cases later for having more than one stat block if you have some sort of weird special ability, but that's way too complicated for this base stuff. We're just going with the design decision of, yeah, a player character is a stat block. That makes sense. But you can't say necessarily they're an HP block. So what are we going to do with HP? It's hit points. Now, all hit points is basically, something that has a max and it has a tracker of where it's currently at. That is not unique to hit points. I don't think it actually makes a whole lot of sense to call this hit points. So we're going to call it something else. We're going to call this a PointWell. So a well is like a well of water or something like that. And it has a fullness level. And of course, it can get to max or it can get to minimum. Can't go negative, and it can't go above the max. So PointWell. And what this means is we can use this for a lot of different things. We can use this for durability. We could use this for currency. We could use this for mana. We could use this for energy. We could use this for rage. It's all essentially the same thing. It's a PointWell. I'm just calling it a PointWell because I don't know what better to call it. So we might have multiple of these. Thus, we're going to use composition on the PointWell. And we're just going to go ahead and rename all these PointWell. And just change these. So we have like set max HP. We're just going to change that to set max. I need to rename more of these variables, but I'll do that later. We have a get max. We have a get current. And this take damage, we're just going to change to reduce. And this heal, we're going to change to increase. The logic is still going to stay approximately the same. And yeah, that should be pretty good. There's one bit of logic I kind of forgot to put in here, and that's if your current HP goes negative, what happens then? Well, since we're using unsigned integers, what's going to happen is it's going to change to a giant number. So we have this current HP minus equals damage. Well, actually, I think we have this handled pretty well because if the damage is greater than the current HP, then it's just going to set it to 0. So yeah, actually we have that case handled. I was thinking here we needed another case in case this wrapped it to a high number, but this initial if statement should handle that. So yeah, I think we're good there. Increase looks fine. And yeah, I think everything else is probably okay here. There might be some edge cases here and there. So we could, in theory, do some elaborate and very thorough testing of this PointWell later, but we'll worry about that a little later, if ever. So HP type, we're no longer going to call this HP type. We're just going to call it well type here. So there we go, well type. And that's not the best name in the world, in my opinion, because it sounds like maybe wellness or health, which that sort of makes sense, I guess, a little bit. But I couldn't really think of anything. I didn't really want to do point type because point type is, there's a lot more overlap there, I feel like, with sometimes you think as points as like 3D points of an X, Y, and Z and stuff like that. So I'm going to go with well type. We could even go PointWell type, but we'll just stick with well type. There's a lot of other variables that need named here, like this new max HP, and everything that basically says HP, we just kind of want to get rid of basically. So we could go through and do something like this and just rename anything that says HP to a blank. So let's just kind of take a quick look here and make sure that makes sense. So we're just going to hit the button, delete all those. And yeah, that looks like it handled that. So we don't see HP. We got an underscore here, which is a little awkward. I guess we get that off of there. But for the most part, we're okay. We have a current and a max of the well type, and yeah, I think that's pretty good. So in general, wait a second. Something weird happened in one of these. Oops. Oh yeah, the constructor. So the constructor is no longer HP. It's going to be PointWell. Very good. Caught that. And yeah, I think we're done with the PointWell. We will save that. Don't see any errors there. We got some weird line with the syntax helper, but whatever it's doing, it's going to take a minute to catch up. So we will, well, wait. It's because we need to put PointWell here as well. PointWell. We have two constructors. One where it's just the default constructor sets them to 1, or you can specify and it does a thing. So that's fine for now. We might change that later, but we're not going to worry about it by auto format. That's fine. Let's close that. Okay, and now we get to some more interesting things. Of course, we already put our Cleric in here in this player character class. I'm going to close down this PointWell and this stat block because I think we're done with those for the moment. We'll leave stat block open. Player character, we have this open twice. That shouldn't be possible. Not sure how that happened. Okay, so we want to open our player character, and we're just going to work on this and go through and do what we got to do as we continue on. So let's look at the Cleric that we pasted in here and see if we can get this worked out. Now I'm also going to do another thing as we go here. This growth rate on this HP, strength, and int and base, sort of redundant to have both of them in my opinion, because we're just making the growth half of whatever the base is. So since that's a formula, we don't necessarily need all these variables, and it's going to clean it up a lot. And that way, when we level up, what we're going to end up doing is just we're going to grow it by whatever the base is, but we're going to half it. So we're going to divide by a float, whatever that ends up being, we're going to cast back into HP type, or well type now. And up here, we need to be sure to include well type, or PointWell, rather. PointWell. The way we get everything from that new HP pool thing. And we're going to have to clean this up a little bit too. HP is no longer going to be constructed like that. Stat block also not going to be constructed the same either. So we'll get rid of that. And we're going to basically redo these constructors. But I just want to get the one sorted out for the Cleric, and then we can propagate that down to the rest. And yeah, we should be able to go pretty well from there. Okay, so the level up, we're basically going to call set max. It says HP here, but we really just want to set max on, okay, that PointWell. So the PointWell for HP is going to be in our player character delegate. I think we're just going to pop it in here as a public. We're going to make this a unique pointer. Unique pointer to a PointWell called HP. Because you only have one, and we want the auto handle. Since we're using a unique pointer here, we're going to include memory. I guess we don't necessarily have to make this a unique pointer here, but I feel like I had some reason for it when I was constructing all this. And I think it's actually, I think I explain it in that last episode that I'm not going to post. If it comes to mind, I'll say it again, but it's not coming to mind right now. But that's the way we're going to do it. And that way later, if we decide we have MP or something, we can put that in here as well as the second one. but we need to make sure that this is not null or uninstantiated or whatever it may be. So it says PointWell is undefined. Why is that? Let's go over back to PointWell. Oh, class. We didn't rename the class, so we want this to be no longer HP. Wait, what happened here? I thought I renamed all these. Didn't we just redo this class? Where'd it go? Oh, no. Okay, well, I guess I'll redo it again. Okay, I just popped it back in there. I'm not sure why that didn't save. I must have done something wrong. But yeah, we're essentially going to do the same thing again. Let's just clean this up a little bit. And instead of current and max, it is current fullness and max well. So a little tiny bit of difference in the syntax there, but essentially the same thing. And we're going to make that C and M again, C and M. We just don't want to be saying HP actually in here anyway. So there we go. We'll just walk through this real quick. Our type is now called well type. And we got to set max. We got to get max. We got to get current. We got to reduce current and an increase current. Slightly different name than I said earlier. And we got our same constructors like that and like that. Okay, let's hit save. Make sure it actually saves this time. Not sure why I didn't last time. And close it. Is it actually there? Let's reopen. Yeah, it looks good. That was really weird. Not sure why that happened. But apparently I glitched out something. All right. Very good. So we're looking at our stat block here. Oops, that's approximately the same for now. Let's go back to our player character and keep working on this where we just left off a moment ago. All right, so we were instantiating that PointWell as HP. So we're getting that composed in there. I think no matter what, your player character is going to have HP. But the reason we don't necessarily want to put you know, in some games the rogue has energy, warrior has rage, stuff like that, like World of Warcraft. We got to decide that later, but it's not all of them. So if they do have that, we will put it down in their class type rather than in the delegate. We will compose that since it can have more than one of these point wells, and I think that makes sense. Now in this cleric here, let's keep working on the cleric and get this all sorted out. We're going to redo this constructor. This HP now type is now well type, and we got base HP. We'll keep these the same for now, and we just got some bases. So let's work on this level up real quick here. Basically, we want to call HP set max. Now, HP, of course, is a pointer, a unique pointer, and we need to absolutely make sure that it is actually getting constructed and set up. So we're going to do that in this default constructor here. We're going to say HP equals standard make unique PointWell. And it's going to want some stuff to construct with. We're just going to leave it blank. And that way it uses the default constructor on the HP, which is just going to set it to 1 and 1. Yeah, I think that's fine for now. Yeah, later we will use, I guess, set max in the constructor probably to set the max to what it should be for the class. But yeah, let's just start it as a 1-1. So that way, if you maybe have a class later that's just really basic or something, yeah, I think 1 and 1, just 1 hit point starting out is fine for our particular design. All right, so let's work on this level up. We might be getting a little ahead of ourselves. Let's worry about the level up here in just a second. I'm just going to comment it out for the moment. So in our constructor, what do we want to do? Basically, in our constructor, we just want to set up the HP and the stats for now. That's all we really want to do. And so the way we're going to do that here is we're going to call the base constructor of the player character delegate. So it does its thing. And that's going to set current level to 1, XP to 0, your next level XP at whatever level 2's at. Just get all this base stuff, and it's going to set up our HP well. We want to make sure that all gets nice and set up, and it's going to do that. And then we want to set it to the cleric's HP. So we'll go HP, set max, and base HP. There we go. And we'll also call HP. Let's just make sure they actually have max hit points when they get instantiated. So we're just going to increase current, and we're also just going to increase it by the base HP. And if that ends up going 1 or 2 over, based on the logic of increased current, it's just going to set to max, like so. So that's just fine there. So that gets their HP sorted out for that particular class. And we also want to get the stats sorted out for this particular class too. So we need to take a quick look at our stat block here. What does our stat block do? By default, it sets strength and intellect to 1. We're going to change this just a little bit, I think, here. I think we are going to default it to 0. So if you don't tell it anything, your stats are just going to be zeros, which might potentially mess up some math later, but I think that's fine. We could still instantiate it with this sort of thing, but since it's going to be default constructed in our character delegate with this public stat block, I guess we should actually have it here, like stat block. And yeah, let's just make these zeros. Yeah, let's do it this way. Because we might use a stat block in different ways. Okay, never mind. We'll leave this the same. If you use the default constructor, you get 1 strength, 1 intellect. Sure, fine enough. We may or may not even use that, to be honest, because we'll see. We're going to use this explicit one for now and set it to whatever we say. And we're just going to make them zeros for player characters because we want to use the increase function to set the defaults. And yeah, that should work pretty well. So let's go down to our cleric, and we're just going to call increase stats. And then we want to put base strength and base int. So since they start out with 0, increasing them by their base will give you your nice defaulting starting stats. It's just the way we're deciding to design it. Trying to future-proof it a little bit, thinking we're going to use that stat block for maybe a lot of different things eventually. A lot of different NPCs and monsters. So this is the design we're going with for now. So this should be pretty well for that default. Now let's talk about our level up. We want to increase our max by half of the base. And of course we need to get whatever the max HP is. But HP is a little different now. We don't have a get. It's just a HP get max. Sometimes this they say not to do it in this way necessarily, but it's going to work fine for our case, and if we need to refactor that a little later, we can. We're going to do the same thing with increased stats. We're going to use whatever the base is, divide it by 2. It's going to cast to a float, and then we're going to cast it to stat type. And I guess I can talk a little bit about math here and some order of operations. So we got to be careful about this. The innermost parentheses will calculate first. So we want to make sure we're not casting base strength to stat type, then divided by 2, because it's going to turn into a float. And while it looks like we're casting to a stat type, we might accidentally be casting to a float. So we just want to be careful about how we do these. We want to make sure that we have our calculations inside parentheses. This is not necessarily required. There are different ways of doing it. I just think personally it makes it a lot clearer when you have all your operations very specifically defined within parentheses. So example, let's go like this on this HP one, and I'll explain very quickly in case you don't know. So our innermost parentheses is this right here. It's going to do this calculation first, and it's going to cast to a float. So base HP 14 divided by 2.f, it's going to be like a 7.0 float. And then we're going to work out the next parentheses, which is this. So it's going to get this max HP, and it's going to add it to that float, and then it's going to cast that to well type. And that should be pretty accurate for what we're doing. There's going to be some automatic rounding. Generally, whatever the automatic rounding is if it just casts to a type that doesn't have decimals, is it just cuts off the decimals. So basically it's an always round down case. We might want it to always round up or something, but we can address that later, or we can apply a little magic to make it a little more player friendly, we'll say. So for example, what we probably want to do is on your stats, we probably want to just add +1 to this base before dividing. That way it gives us a round up. So in our case, it's gonna, half of the strength is going to be just 1, so you're going to get 1 more strength per level up. But if we're going to reuse this code, sometimes people have like odd strength, like 3, and it's still only going to give you 1. Maybe in that case, we'll only give you 2. This is just going to make it round to 2 if it's odd. So it's just going to make it round up rather than down in a lot of those cases. I think we'll do the same thing here. Well, this should be base nth. That could cause some bugs. +1u. So we're just going to round up on those odd cases just to be a little more user friendly. Because in this case, they would only, if we didn't have this +1 or some kind of floor or math operation, we could of course include C math and put that floor or something in there. But this, we'd rather have just a +1 in here than including a whole nother header for now. Is the reason I'm doing it this way. Okay, so this is looking pretty good, I think. Yeah, so base int, it's gonna calculate to 4 and then half that, so they're gonna get 2 rather than the 1. Just some math rounding stuff. And what doesn't this like here? We got to maybe in parentheses again. So there's this one, that's the strength. And then there's, okay, we need another parentheses right here. There's this one, that's the int. Okay, so there's that level up. And the cleric is actually looking pretty good here. So yeah, we're not quite ready yet. We still want our final delegate. We don't actually want to instantiate cleric by itself. Rather, we want to delegate these classes so that in your main you can call player character. So we need to make player character. We're just going to put that way at the bottom here. We're going to make class player character. And in this one, you're going to see we don't inherit anything. Rather, we're going to have in here a player character delegate that is a pointer, and we'll just call it PC class or player character class. All right, so that's private. We'll just make it very explicit here and put private here. And publicly, what we want to do is we want to have one constructor, and that's one that takes the class. So let's actually go player character. Let's take this default constructor and just make sure it doesn't exist with delete. That way no one tries to use that. And we want to have player character that takes a pointer to player character delegate. So we can use some polymorphism on this bad boy. Let me make sure I'm still recording. I'm having nightmares, flashbacks of last episode where I accidentally turned the recording off. Oh, okay. This episode's going to be a little bit longer. That's fine. We're actually getting pretty close to done. Just a few more things here. But there's been a lot of lessons in this one, so this is a pretty important one. All right, player character delegate. We can name this anything. I'm just going to call PC. And what we want to do here is just say that whatever that PC pointer we're pointing or passing into here, we're just going to say PC class, or actually, let's construct here. PC class is whatever that PC is. And that should take care of it. So what's going to happen now is when you instantiate a player character, you got to call some valid class delegate. And of course you can't pass it this player character delegate itself because it's pure virtual, so you need some overridden version of it to pass. Right now we have a cleric that is currently valid. That's the only one we have in here for right now. So let's actually go over to our main and just see if this works with cleric. Seems to be taking a minute to figure out whether it's happy or not. Okay, it does look like we need to make this get class name method, and we might need to fix up a few other things. But overall, this actually should work. So maybe we just need to recompile. Give me just a second. All right, let's go back into player character. Let's make this other function here. We're going to use string, and we're just going to, string buff, get class name, and all this is going to do is just return, well, we'll construct a string, not a string buff, auto formatting that, Cleric. So we'll just do this for each class we make. That way we can call get class name on it. It'll automatically construct. Now it doesn't know what a string is, so we just have to include it. If you know a better, faster way of doing this, awesome. You're welcome to make a pull request on that. But C++ isn't super good at having ways of getting class names as a string. I think there are some ways of doing it with macros, but we're just going to simplify it and just do this in each of them. That way we can just call later in our code get class name like so, and it should just work. All right, so what's the problem here? Why doesn't it like this? All right, we're going to hit compile. Compiler says player character, no such file or directory. So we just spelled it wrong. Character. That's a C in there. That works. Hit play. Yep, still complains. It basically complains that player character doesn't have these functions, and it's right. It actually doesn't. So if we look at our player character, this is kind of our main interface one that we actually construct. We're not inheriting from everything, so it only very literally has what we have here. So basically, we need to delegate these out and call the functions that we want to call. So we kind of need to do some code duplication here, which is a bit ugly, but for like get class name, what do we want to do, right? We want to have, okay, string, and we'll have make this again, get class name, but rather, well, we don't necessarily know the name of the class, but you know what does? This PC class, because it's in here. So this PC class is always going to have that. Actually, you know, we're doing this a little wonky. This should actually be virtual as well. So virtual void get class name equals 0. Oh, not void, string here. So you have to implement this as well. And we will do that. That way we make sure it has it for the delegate. So we'll just do the same thing here, except override. And there we go. Looks pretty good. So now we'll have PC class get class name. And that is just going to return the whatever type that this ends up being. So that's pretty good. We're going to need to basically do that for all these that have an error and anything else we want to be publicly available. And we can even rename them slightly if we want to, like this get max HP of the player character. That's actually going to be a little different now because let's see what, yeah, that's going to be just part of this PointWell, and it's going to be get max. So that's fine, but I think in our player character delegate, we'll have it called get max HP, and then it's going to call HP get max. Hope that all makes sense. We're basically going to be doing a lot of typing here and getting this all sorted out. The next one is get level. It says it doesn't know about that. It says it doesn't know about a lot of different things here. So we just basically got to sort all those out, and then we'll add in the rest of the classes. Right now we're just getting set up with Cleric, and then we can expand later. So as you'll see by the end of this and learn that you'll be able to very easily add more classes, which will be great for expanding. Say we have an expansion that comes out where we add a berserker. We'll show you how to do that at the end. It makes it super easy to do that sort of thing. So this is definitely the right way to be doing this, I think, for our cases. So get level is going to return level type, get level, and it's going to, once again, use this delegate of PC class, get level, and there we go. So that'll forward it to the proper one, whatever we instantiate. This as. Now this also kind of brings up another thing that I wasn't thinking about necessarily earlier, and that's since we have a pointer here, we want to also make sure we're controlling the destructing of it. So if player character gets deleted, oh, let's make the tilde in front of that. We want to call delete PC class, because we need to make sure this memory goes away if this class goes out of scope or something, otherwise it won't. And then we'll just go PC class equals null pointer. That should take care of that. That also gives us the option to do maybe some cool special stuff later, like maybe we want to have a respec option where you decide, hey, I don't want to be a rogue anymore, I'd rather be a warrior. We could call this destructor and then instantiate as a new warrior and then give it the levels, and then you'll be able to do all your level ups as a warrior. So it just makes stuff like that a lot more simple. So pretty cool. Did I spell that wrong? Yes, I did. Player character has a C in it. All right, and let's just keep building these functions. We're just going to go through and plug away. What else we got? We got get current XP, which returns an XP type. Get current EXP, PC class, and these are just going to keep forwarding these functions. It's delegation method get current EXP. And what's the next one? Get XP to next level. Copy that line down to next level. And let's name the same thing. Some of these are not going to be named the same thing, as we'll see here. We got well type get current HP PC class HP get current. So that's a little different there, since we're going to have different wells. But for this player character, get current HP is nice and clear, and it does what it's supposed to do. And if we add MP later, we can add the other method. We also want get max HP. It's going to be very similar, except instead of get current here, it's going to be get max. And we have get strength, which is going to return a stat type. Get strength. PC class. Now this one has it directly. There we go. Same thing for intellect. Anything else? We need gain XP at the void method. Gain EXP. PC class. Gain EXP. And we need an amount of EXP, of course, so we need EXP type amount, and we'll just forward that amount so they get the experience for their class. And let's see, we also need some ways to take damage and heal, so let's go ahead and add those in. We're just going to call it take damage in this case, and that's going to take a well type PC class HP, and we have an increased current. Oh, we need to put a variable name in there. We'll just keep using amount. So increase it by whatever that amount is. And we're also going to have a heal. Heal for some amount. Oh wait, this one should be reduce current, my bad. And this one's already correct with increased current. So there we go, we got those methods forwarded correctly. And we can make more as needed if we need to. But I think for now that works. So let's go ahead and hit play. Complains a little bit. Get max HP is not a member. Okay, what did we name it? We named it get max HP. Okay, what is it complaining about? Player character has no member, get max HP. So yeah, it does. It's right here. What did we do wrong? Okay, it's capital HP. So I just missed the capitalization. A very little mistake there. We're going to hit play here. And it complains about just a few other things. Get intellect must return a variable. Yes, very true. So we should be having return on all of these that are returning something. Kind of a no-brainer there. Just overlooked that. Boom, boom, boom. Now let's do it. And there we go. So we instantiated our cleric. Let's make sure he's all leveling up correctly at level 1, 0 XP. Max HP looks good. Strength looks good. Intellect looks good. Okay, levels up. It gains half the max, 7 more HP, up to 21. Looks good. Strength, 1 more strength. That's half the base. Looks good. Intellect, half of 3, rounded up, as we intended with our thing there, is going to be should be 2 more. So yep, goes up to 5. Looks good. Let's just improve our formatting a little bit. This is max HP. Let's just turn this to HP, and let's do a similar thing that we did with the level P1. We'll do a get current HP. Add a little slash here. Oh, this slash is a character actually, so there we go. So now there we'll have a how much out of how much type of deal looking thing on the HP. Yeah, 14 to 21. Okay, as we see, we level up. We don't get our new XP added to our pool. Let's go ahead and fix that real quick. That's just going to be in that level up code. Okay, so level up code, set max HP. We just want to increase current as well. HP increase current. Same number. Since we're doing this calculation twice, maybe we just want to get the variable. Or actually, we don't just. There we go. Let's just do this. There we go. So we also increase it by whatever we gained, which is what this calculates to. Just doing that calculation a couple of times there. And that should now give us our new HP. There we go. Some games give you a full heal when you level up. We're not going to do full heal. We're just going to say however much you gained, you're also going to heal for that much. That way you get all your new hit points. So that's going to be the way we do it there. Okay, so that's all looking really good for the cleric. What about the rogue, warrior, wizard? And how do we avoid typing this exact same code over and over? That I will show you. Okay, so what we're going to do is just go to each of these classes, and we just want to grab all this stuff. Now, it's really the same as the cleric, as we might know. So we could actually even just copy down this whole cleric thing like so. So, boom. Change this to rogue. Change this to rogue. Just quick renaming here. A couple renames, not a huge deal. And then we will have all the same stuff. The bases are different for a rogue, so we really just want to sort that out. 12, 3, and 2. That's easy enough. 12, 3, and 2. And there we go. Just like that, we have added a rogue class. We can delete this file. We don't need it anymore. But now in our main, we could say new rogue, hit play. And it's just so easy to extend this with new classes. It's a beautiful thing. Oh my goodness. So look at that. We got the rogue. There's the base HP, strength, intellect. Goes to level 2. Adds 6 more hit points. That's correct. Adds 2 more strength. That's correct. Adds 1 more intellect. And it works correctly. So as you can imagine, we're just going to do the same thing for the warrior and wizard and just put their bases in there. So pretty straightforward. And I want to show you just one last little trick before we close this all out. Warrior, warrior, warrior. Fix those bases. 18-4, 1. 18-4, 1. Got to remember that because I'm going to type it in manually. 18-4, 1. And we can give it a test. Warrior. And just by changing that one thing, we get everything correct. Says the right type, increases correctly. Look at this beefcake. The best strength in the game, the most hit points. Well, yeah, we'll see how that works out. I feel like the warrior might be a little OP, but we'll see. Speaking of, little prelude here. Next episode, episode 5, we're going to be starting to dig into enemies and combat. So we're going to start getting our combat system going. Oh boy, I'm so excited for that. All right, let's get the wizard in here. We got a 10-1-4. Okay, let's just do the same copy down. Change this to wizard. Wizard, wizard. And what was it? 10-1-4. 10-1-4. Delete this class, or yeah, this file rather. No, we could also instantiate as a wizard if we want. Hit play, make sure that looks good. Yep, I think that looks fine. 10 HP goes up. We're gonna elect. Yep, okay. So wizard's looking good. And now, yeah, we're mostly done. But there's one thing I want to address here, and that's this level up code and this constructor. They're exactly the same. There's really no difference on any of them. So we want to come up with a way where we don't have to retype this code, because currently this is 177 lines of code. Yeah, we're sure we got a little bit of redundancy here. But what we can do here is we can use the power of macros to handle this for us. So let's do that. In the macro here, macros are something pretty important to learn. You might need to look them up. We're going to use a very, very basic method of them here. But you can see these a lot in code. Sometimes they make it confusing. So let's go ahead and do a macro. You do this hash define, and then you give your macro a name. We're going to call this first one PC construct in all caps. And then after this, it's this is the code. So there's its variable name, and then what it does currently, it's just like a blank space probably. PC construct will define as nothing. But we want to define it as this whole chunk of code here, basically everything after the class name. So we're going to hit, I just hit Control X there. I'm going to go up here and Control V, so paste it in. Now, macros don't understand new lines, so when you put a real new line in there, it ends the macro. So we would have to put this all in one line, but that's going to be a little hard to read. So what we're going to use is just backslashes for new lines, to eat the new line rather, to say ignore this new line, ignore this new line, ignore this new line, ignore this new line. And there we go. Now it's essentially all one line. It just doesn't look like that in our code. But now, instead of typing all that out in all of these, we can just put PC construct right here, and that'll work. And we can do that for all of them. So let's go down to our rogue, PC construct, warrior, PC construct, PC construct, wizard. And since they're using these same named bases, that's why we can do this, because the code is exactly the same on all of those. And we'll go ahead and hit compile here. It's going to recompile, and as you can see, it still works fine. And now the level up code is also exactly the same, so we can do the same thing with that. Let's go ahead and do another define. This is of course optional, but I like to do it if there's a lot of repeating code. And we're going to put in here level up. And what's it define as? Well, it's going to be exactly this code. So I'm just going to cut that and paste it right here. And of course, anywhere there's a new line, let's put that slash, 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 and leave the new line at the end, of course, so that it actually ends the macro. Okay, and now anywhere where it says level up, or it's level up code, we can just put literally here, just plain old level up, and it's going to paste in all this code for us. So we'll just do that privately in each of them. Whoops, let's copy that level up. And let's just put it right there. Level up. Level up. So essentially what we start to have here is just like a nice clean base template that we could use for any new class. If we ever want to add in another class, we just use the same template, rename this keyword to whatever the new class name is, change our bases to whatever it is, and it's going to do everything pretty much automatically, which is extremely, extremely nice. And maybe I'm doing something that Visual Studio is not liking, but it looks like it's giving me some little underlines here. And let's see, what does it want to do? What is it complaining about? Consider adding a hint file. I don't normally do that, but it looks like if we go to quick actions and refactoring or hit alt enter over it, it says add macro PC construct to new C++ hint file. I don't know, do this if you want, I guess. It seems awkward to me just because I never do it. Maybe someone can explain the elaborate point of that, because I'm going to be honest, I don't get it. You could literally just look at the macro here, right? So I'm not sure what the point of that is, but it wants us to do it. I'm not going to do it. I'm going to skip it. Another thing it's doing that's a little awkward is it's having a little trouble with the syntax formatter. Like if I auto format this, for some reason it double indents this get class name. Not sure why it does that either. A little weird. If it's resolving as this code, it should understand that this doesn't need double indented. I'm just going to put it above the PC construct thing in this case, just so that my auto formatter stops being weird. So just moving all these up for our template. So now we just have a very nice template. We could even take this a step further by making another macro that takes a name and takes some bases, and we could just like expand this further. But I'm not going to worry about that right now. That gets a little complicated in my opinion. Let's go ahead. I think we want to space on these. It doesn't matter a ton, but yeah, this looks really weird for C++ code, but basically these words are just resolving to this code every time. And since it's exactly the same, this is a perfectly fine thing to do. It's something you can do if you find yourself repeating the same code, but can't exactly turn it into a function. This sort of thing will work often. Just making it a macro instead is going to clean things up a lot. All right, cool. Let's run this. Make sure it all works. Looks good. Still instantiating a wizard. And now, just as a quick example, berserker here. Let's say we add a berserker. And that'd be very simple to do. We basically just want to take this, go like so, rename it to berserker. I'll leave the berserker in here, why not? Change all of that to berserker, give some base HP, start them out at 20. Let's do the same as the warrior. I don't know, we need to make design decisions, and I don't necessarily want to, but let's just say he has 5 strength and still 1 int. I don't know, just another thing we could do. And it's a berserker. That it should just work now. Now we've got a whole nother class with a whole new scaling system, which is some very easy to maintain and update code. So that's the whole point of this delegation thing, compared to the way we were doing it before. Just now that this is all set up, it's so easy to maintain and update and add to and expand. So yeah, I hope you got a lot out of this episode. I hope you enjoyed. I really enjoyed doing this. This was really fun for me. This is probably the most fun thing in the world. This is like the only thing I ever shut my phone off for, because I enjoy it so much. So that's pretty interesting. I'm going to delete the berserker. We don't actually, it's not in our original design. Maybe that's for an expansion later. But there is one drawback in here, and I couldn't think of how to fix it, and that is that people, if they're using these classes, they could just instantiate a warrior still, rather than using this method here. They could go, let me just comment that out. You could still go warrior, and that's valid, So I guess my question would be, how do we make this invalid to make sure nobody does this? Because we're not going to get what we want. I guess you could still do all this stuff, but we don't get the forwarded methods. We don't get this player character stuff. We only get whatever's in whatever class we implemented. So we wouldn't get this heal and take damage. We would have to use whatever we're doing here, which maybe is okay, but it starts to get a bit, it's not what we intend. So if you know how to fix that and have some great idea off the top of your head, consider leaving a comment or working on the code over on GitHub and making a pull request. Up to you how you want to do that. But yeah, that's today's episode. And let me know what you think down below. Appreciate you guys a ton. You can support me by, well, there's tons of links everywhere. I'm not going to say everything. Yeah, I just know that I really appreciate you guys, and I really love doing this. This is great. Hope you're enjoying it as much as I am. I'll see you in the next one. Peace out, guys.